Hello everybody, welcome to week 2 of our online learning, and this week we're going to talk about logarithms. I've broken it apart into 3 videos, and each part's going to further on what we know about logarithms. So, the first part is this is what a log looks like. Now, the B stands for base, and A could be any number, and we can type that into our calculator, and it'll give us an answer. Now, there are 2 ways to write logarithms. This way, where you actually have a log, and then the exponential way. So, whatever number is in place for A is going to stay in the same spot. Now, the base of our logarithm there is now going to be the base of an exponent on the other side. This is really, really important for us to know, to be able to go between these 2 things. We can start at one and go to the other, and vice versa. This is how we're going to solve our logarithmic equations. So, for example here, if we have log base 3 of 9, that's going to equal 2. To change it into exponential, the 9 is in the same spot as A, so that's going to stay where it is. The base of the logarithm is going to become the base with an exponent, in which case we see these 2 things are exactly the same. Now the question is, what happens if the base is not written? For example, like this, the log of 6 equals y. Now, the base then of the logarithm is automatically 10. We just assume that, and we don't even have to write it. So to change it to exponential, we're going to say leave the 6 alone. The base of the log is 10, which is now the base with an exponent. And we can go, once again, back and forth between these 2 to help us solve equations. Now, a couple things to know about a logarithm. What is it actually asking? Is that if I have log base 10 of 100, remember we don't have to write the 10, we have to figure out what is that going to equal. Well, this is just saying whatever the base is, the base to what power gives us 100. So 10 squared is 100, and that's what logarithms do. A couple extra things you need to know is if the base of the logarithm is the same as that number there, it's always going to be 1. So log base 12 of 12 will be 1. The log of 10 is going to be 1 because we know that the base there is an invisible 10. So that might help you out here in the future. So let's do a couple examples here. We are going to solve for our variables on all of these. So we start out with an exponential. Now, sometimes these might be easy. If it was 6 to the x power equals 36, we can kind of figure that out by ourselves without the help of logarithms. But what we're going to do is take this exponential and change it into the logarithm like we know. So, if needed, how we've been writing it in the notes was maybe we need to switch this. Now, the base of the exponent is then going to be the base of the logarithm on the other side. And that exponent, the x, will be by itself. So this is actually the answer, but I want you to go ahead and type this in your calculator and get the decimal. If you have a fancier calculator, you actually have a button on there under math, I believe, to type log base 6 of 20. If you have the TI-83s, I don't believe you can type this in. The way you do it then is we do have just a normal log button with the base of 10, And how you would type it would be like this. And everybody, no matter what calculator you have, you can type this. These two things are exactly the same. And the answer you should get is 1.67. So go ahead and type that in your calculator and make sure you get that correct. Example 2 for this video is going to have a lot more involvement. So this has a lot going on. Not only do we have the base 8 with an exponent, it's being multiplied by 2, it's being subtracted by something, so there's a lot going on. The first thing that we want to do is isolate that base and exponent. So this part right here, we want to get by itself. So I just want you to kind of leave that alone and get rid of everything else, i.e. the 2 and the -7 here. So just like normal solving, we are going to add 7 to each side. And that's going to equal 28. Normal solving will divide by 2. So then we just have 8 to our exponent equals 14. And once again, now we just have to change this to be logarithm form. So the base of the exponent then becomes the base of the log on the other side. And the exponent is by itself. And then we just solve like normal. I'm going to go ahead and erase this and rewrite that last step. So now we just need to solve for x. So we subtract 4. And what's really important to know is the -4 is not a part of the logarithm. So when you type this in, it's going to give you parentheses with the logarithm, so make sure you end your parenthesis after the 14. And then we'll divide by 3. And remember that log base 8 of 14 is the same thing as just taking normal log of 14 divided by the log of 8. Go ahead and type that into your calculator and make sure you get the same answer as I did, -0.910. Make sure you round to 3 sig figs, please.